Now we're going to look at some oxidation reduction reactions.
So now that we know how to assign oxidation numbers, we want to apply them, right? We want to be able to, the whole point was we wanted to identify reduction oxidation reactions. So if I look at this case, this was something that I said I would know, I could see things are changing cations, things are becoming ions or not becoming ions. So I want to be able to look at it and know what is being oxidized and what is being reduced. And so the process there is always going to be, I'm always going to start out with by, assigning oxidation numbers. And so in the case of this, I only have ions or neutral species. So my oxidation numbers are going to follow directly from the charge, right? Nickel 2 plus has an oxidation number of +2. Chromium solid is elemental, so it has an oxidation number of 0. Then once I assign oxidation numbers to each atom type on each side of the reaction, now I can look at changes in oxidation numbers across the reaction. So nickel goes from +2 to 0. We can see it's +2 on the reactants, 0 on the products, whereas chromium goes from 0 to +2 as it goes across the reaction. So we can see there's this change in the oxidation number as I go across the reaction. I'm comparing reactants to products. Then if I look, I can see that nickel, that's a decrease. +2 to 0 is a decrease. Chromium, 0 to +2 is an increase. A decrease in oxidation number is reduction, and an increase in oxidation number is oxidation. You can see for reduction, there was a gain of electrons. Oxidation is a loss of electrons. Oil rig, Leo Ger, we want to be remembering those things. And so just like we assign oxidation numbers to each atom type, individual atom types are always going to be associated with reduction or oxidation. So whenever we're faced with figuring these things out, what's oxidized and what's reduced, we're always going to look to compute oxidation numbers and then look at how they change across the reaction.
You can complicate this just a little more, get a little more language, and that is talking about oxidizing and reducing agents. A lot of times when we're doing chemical reactions, we want to think about what we can make happen, what we can cause to happen. And so an oxidizing agent is something in the reaction that causes oxidation. So it is the thing that gets reduced. Remember, these two things have to be happening at the same time. So something that causes oxidation, it makes another substance, another atom, molecule, whatever, undergo oxidation. And so that has to be reduced. So in a reaction, if you identify what is reduced, what you're identifying is the oxidizing agent. Conversely, whatever is oxidized can be called the reducing agent. Reducing agents imply that you are causing this change, right? Something that causes reduction. You're an agent, right? You are an agent of change, right? An agent of reducing. You cause that. And so, if we look at, another example where say we have zinc solid reacting with copper 2 plus, the zinc is oxidized there and the copper is reduced. Well, instead of talking about that kind of passively, we could also say that the zinc is the reducing agent. It caused the copper to become reduced, to undergo that reduction process. Copper is the oxidizing agent. When we're defining these things, when we say something is oxidized or reduced, that's going to be a specific atom type. So carbon, hydrogen, oxygen, copper, zinc, whatever it is. Oxidizing agents are always substances. So something about the substance, some sort of information about what you're using. A lot of times this language of oxidizing agent, it can apply to a particular reaction, but also more generically than that, we just kind of use it to describe things that are good at causing oxidizing. So that they really tend to reduce in reactions, so they can cause a lot of other things to undergo oxidation. Hence, they're oxidizing agents. We're still going to apply them to particular reactions, but that's why there's this different language. You're talking about substances that you can use for particular reaction types.
So we can put this all together, get all of our lingo. In the following reaction, what is oxidized and what is reduced? What is the reducing agent? What is the oxidizing agent? If we look, we can see this is a combustion reaction. So we do know off the bat that it is reduction oxidation. So there's going to be something that's oxidized and something that's reduced. But it's not going to be it's not easy to identify what is what in here. So I have CH4, I have O2, CO2, and H2O. And so the first step is always going to be assign some oxidation numbers. Get oxidation numbers for each atom type on both sides of the reaction. So we can see, O2 is elemental, it's 0. And all of the species that hydrogen is in, hydrogen takes the +1, and so the other species just takes whatever charge makes it neutral, and our carbon is +4 in that CO2 to balance it out. So we can compute all of our charges and see all the oxidation numbers for every atom type on both sides of the reaction. So once we have all those, we want to look at changes in oxidation numbers. If we look, carbon is -4 to +4. That's an increase. Hydrogen goes +1 to +1. That's no change. And oxygen goes 0 to -2. That's a decrease. So we can see that increase in oxidation number for carbon, that means it oxidized. Decrease in the oxidation number of oxygen means that it decreased. Okay, so that means the carbon atoms were oxidized and the oxygen atoms were reduced. Okay, so carbon's oxidized, oxygen is reduced. You'll see we assign that language to a particular atom type. The next question was the agent question. And so in that case, we want to then look at assigning particular compounds. So we can see that carbon was oxidized. So that means the molecule that carbon was in this case, the CH4, is the reducing agent because it made the other thing do reduction. O2 is then the oxidizing agent. Okay, so oxygen was reduced here, but the O2 molecule was the oxidizing agent. This right here is actually where all of this language comes from. O2 is a really good oxidizing agent. Oxidizing meaning react with oxygen. So one of the things, it's very confusing, I know. Reduction being gain is on face confusing. But it all comes from the idea that oxygen is, people figured it out before they knew what was going on, that it was reactions with oxygen. So O2 is the oxidizing agent. So one of the ways you can always check yourself is O2, are you saying O2 is the oxidizing agent? That's a place you always want to be. And, and always reactants that contain those corresponding atoms when we're looking at agents.
Those are the 3 types of reactions that we can do. It's been a lot, but we started with precipitation reactions, where you exchange ions between compounds, you form a solid. Acid-base reactions, exchange of H+ ions between acid and base, you make a water and a salt. Importantly, both of those reactions follow that double displacement pattern, which enables us to predict their product. You can predict the products of those reactions. Oxidation reduction reactions are then the transfer of electrons. We cannot predict the products, but we can characterize those reactions and see how electrons are flowing. So, and if we look at kind of all these patterns, we can start to see that a lot of these reactions that we use a lot are pretty small reactions, right? Or small changes, exchange ions, exchange H+ ions, transfer electrons. Those are the kind of chemistry that's very controlled, small changes. Those are what make these things, we are able to predict them. With electrons, it is possible to predict the oxidation reduction. We just can't do it quite yet. Got to come back for Gen Chem 2 if you want to learn it. But there is a way to do it because it's a relatively small change, makes it more predictable. But precipitation, acid, base, we can already predict right now. Okay, 4 questions on participation 612. You want to find all 4 of them, get them answered, and get those answers submitted over on Blackboard by Friday night. For Saturday, post-lab for the reactions of copper lab is due, module 4 homework is due, and don't forget, on Sunday this week we got an assignment, the lab group 1 evaluation. We're going to rotate lab groups, so you will talk about answer questions about how you'll rate your group's teamwork, how well y'all work together, how much you contributed to the group, what y'all did. So we want to make sure you get that in on Sunday. Simultaneously, next week, you're going to be in a new lab group. And so that means I'll set those on Sunday. I'll change your lab group and I will make new pages in the lab notebook. And so you can check there Sunday, see, you might be in the same letter, but you'll be with new people, and I will assign responsibilities. Who's the leader, who's the technician, who needs to get their parts done before the lab starts, before lab on Tuesday. If you have any questions about anything, let me know. Otherwise, the only thing that's left is answers to the participation will go live Friday night. Otherwise, that's it for me. That's it. Have a good weekend. Next week, week 3, we do it all over again. I'll see you there.